And to finalize this, I guess I'm going to introduce John. He works for Fannie Mae, new customer of ours. We have been working closely with him to introduce parallel file system technologies within Fannie Mae. He's actually worked for IBM for a while as well. 5 years of Fannie Mae, if I'm not mistaken, and a bunch of IBM and platform, and now he's back at Fannie Mae again. So I'm going to give it over to you. You can get the video screen.
All right, is this thing still on? Everybody hear me okay? Okay, great. So, at Fannie Mae, we had a problem. We were siloed, and we needed better performance. By implementing a DDN grid scaler using a KX, we achieved about 450 to 500% improved performance in our SaaS workflows. So we went through, we had to figure out how do we address this. So we knew that, okay, we can't push this data over 10 gig Ethernet. So we implemented InfiniBand, running everything on RDMA with GPFS. We eliminated TCP, higher throughput per core. We had a requirement of 100 megabytes per second per core. IB gave us that capability. So one of our biggest applications that was running on this environment was SaaS, and it achieved 450% improvement in time. So everybody probably has heard of Fannie Mae, probably not for sure what we actually do in the back end. So we actually are the leader in the secondary mortgage environment. We buy securities from banks, repackage, resell. So we had to come up with ways to do things better, faster, cheaper. And to do this, we had to build something new. If we were going to lead the enterprise and lead the market with making things better, we had to do something new. So our risk analytics frameworks, like most places, is varied. We have SAS, YAR, Informatica, Ab Initio, MATLAB, and a lot of proprietary internal code. We have daily, weekly, monthly, quarterly processing that must be done, and if we don't do it, we get fined. The common workflows, large data sets, and we have to do a lot of analysis across a large amount of data. A lot of this workload is time sensitive. If it is not processed within a timely manner, we get fined for every minute. Some of these workloads are $1 million a minute fines, which can get expensive if we don't meet the deadline.
We should have charged more.
Let's talk to the Treasury Department about that.
I told you we gave it away.
So we have some extremely compute and I/O intensive workloads. Who doesn't? It's HPC after all. Numbers of users that were using this environment is constantly scaling. We have over 400 different applications running analytics in this one environment with over 100 different users. So we were hitting bottlenecks on the I/O. Of course, everything was SAN-based. Well, SAN is going to be limited. It's going to cause a limit there. So what was happening was we could only run subsets of the different applications during the time frames that we wanted to run. To do that, well, some results were good, some were not. So we needed a storage infrastructure to eliminate the silos. So this team had their SAN infrastructure, this team had theirs. It was a mess all across the board. So turnaround time, slow. Something had to be done to speed it up. The throughput caused a lot of OpEx and a lot of CapEx expenditures on a constant basis. And this limited our capabilities to function effectively and provide things with our stakeholders. HPC sprawl. Our data size footprint was growing and growing, and we had to figure out something to do. And as the sprawl increased, so did the complexity, so did the cost. So we needed something that had high performance for data-intensive applications, We needed to eliminate the I/O bottlenecks of these different silos. Minimize the runtime. If it runs faster, it finishes faster, and we make more money. Enabled a scalable growth path with reducing complexity of the whole system. But we also had to have seamless integration into the rest of the infrastructure. That's where GPFS with POSIX compliance came in. Of course, we always have to minimize our expenses. Everybody wants something, but nobody wants to pay for it. So we did POCs and design exploration with DDN. This was actually a pretty long process that went through our SAN environment that was existing. We were about 20 to 30 megabytes a second per core throughput. And this was running on some big iron machines. These are some IBM P770s, some Sun boxes, old 6900s, etc. It was very poor per core throughput. It was lousy. So started looking at DDN. So with our SAS grid solution, we achieved a 452% faster workflows across the board. Some applications were even higher. Using this three-tier, we have tiers here. So we have the SAS tier. Infrastructure was an InfiniBand infrastructure that we put together, our NSDs, and ultimately to the grid scale. Interesting thing happened. After we implemented this for SAS, word got around to the rest of the groups. All of a sudden now Informatica turned around and said, hey, we want that.
Okay, so as I was saying, we had the SAS grid solution, got very good workflow out of it. As a result of that, the other team, Informatica, which is a subset group under our ETL team, they wanted the same thing deployed for them. It's not quite as large of a system as we did for SAS because it's a smaller group, yet they still achieved the 500% improvement of their workflows, which so far we've been impressed with. And they've already come to me and asked about doing an ab initio deployment, and we're also looking at doing it within our other broader HPC environments that we have that spans upwards of about 15,000 cores. So again, with this, not only did we improve performance, but we reduced cost. And that cost comes from many factors. Not only the cost of DDN storage versus the cost of our SAN storage, which was much cheaper to use the grid scaler than our traditional SAN as a per terabyte costing, it's cheaper. But because we also reduced footprint and HVAC, maintenance and support costs, we also reduced the silos of bringing down over 100 different SAS servers. We reduced it down to a 16-node cluster running SAS grid with LSF on the back end for the entire enterprise. So we went from 100 servers down to 16.
And how much are the SAS licenses?
SAS licenses are around $25,000 per core.
Who's the account manager?
So SAS was very happy with our performance and with the results. However, they're not very happy about the reduction in licensing costs. So on a per core basis, with the DDN, we were showing a per core throughput 100 times better. So this is what we required. Of this first slide here on the left, that's what we required in order to meet our performance goals. The most complex SAS process on the right, on SAN, was taking, that's the runtime in minutes, about 450 minutes, so it's taken a long time. That was reduced down to 100 minutes running off of the grid scaler on a 16-node cluster. We are very hopeful that as timing goes, we're going to increase the size of that cluster, and this runtime will go down even farther. So this one, Informatica, again, their large job that we were testing against, it was running at about 500 minutes for the job to complete. That runtime was then dropped down to, it's actually a little less than 100, but It's kind of hard to show the little incrementals. So we've gotten really, really good performance with the environment. And so we went from a SAN environment, 8 gig fiber channel uplinks, dual path, multipathing to the hosts. Replaced that with a grid scaler, so it's a 12KX with InfiniBand connectivity throughout the whole thing. Client all the way through, deployed FDR, and performance was just incredible. As far with the risk management workflows, we can now run 5 times the amount of workloads in the amount of time that it used to take to run one workload. So with this, as far as the application teams are concerned, they're ecstatic because now they can run jobs that they never could run because they always ran out of time. And they can now do things that they didn't even think they could do before because now they have the compute capability to achieve higher goals. Again, reduced cost in the data center, minimized our OpEx and support and services costs, so SaaS licenses, but also we reduced the need of maintaining and supporting 100+ servers. That reduced administration costs, patching, care, and feeding of all of that. Next, we consolidated data management along similar lines. So we're being able to bring in all these different silos of data off of the SAN arrays and able to converge all that data. Now, this group doesn't have to copy data from one area, process, copy it back over to this area, process. So end-to-end runtimes were hugely increased. We're now able to easily identify bottlenecks within the system. And through the deployment of the InfiniBand and running everything across RDMA, we eliminated one of the biggest bottlenecks that we had, which was not only to the storage across the fiber channel backend, but also out to the clients on the front end across traditional Ethernet. So now we can actually look at ways to improve other things. We're now actually utilizing the compute that we have with all this compute cycles. That's how we're able to take and put all this workload down on 16 nodes and reduce footprints. We are looking at other options in other areas of how can we exploit InfiniBand and RDMA in other areas outside of this workflow. What else can we start tackling? And we've actually been talking with our VMware team of using a grid scaler for backend or using WAS for that. And this one here is a key one for us here of architecting the data solution for data movement. One of our HPC environments, well, they do a lot of CPU-intensive calculations and modeling against data, but then they take that output data and then do SAS modeling against that output. So today, they're taking from one environment, processing, copying, 50 gig input files of multiple data sets that will result to 50 terabyte data sets that has to be moved from here and put here. Our next steps of what we're doing is implementing grid scaler within that environment so that the units can be connected. No more having to copy data back and forth. So the day of time that they lose purely in data copy, they now get back. Now, if we have time, any Q&A? Yes?
You mentioned that these two groups specifically were differently sized DDN solutions. Were there some reason that they were not as similar to grid scaler, appliances, et cetera?
Capacity.
Okay.
So the SAS was a 300 terabyte environment to start with, and the Informatica was only 200.
So you didn't just throw out what you had?
Not for this particular use case. However, what we did do for our DR implementation, we also have two 7700s in our DR location, which we did do that. That was my next question, was what did you do about DR and back? So DR...
How did that affect the process before and after?
So before, it was a manual process, and they were doing SRDA, replications to DR, manual copying of data as needed. we're in process still of setting up DR fully for both groups, but what we did was on the 7700s, when Informatica came on board, we just expanded the storage, added the storage pools, created their file system, and now we're going to do an AFM replication from site to site to make sure that that data is balanced across the sites. And we only replicate the production data, not our lower environment research data. Any others?
Thank you.
Welcome.